Hi, this is Chuck Stull, continuing our look at semiconductors and looking at the idea of learning curves. I want to really be careful of what I said. The semiconductor production process is more than just printing. It is a very difficult process to master, and initially there'll be a very high rate of defects, right? So low productivity. We will have the whole system set up, but a lot of the chips won't work, and that's going to make costs very high to start with. Now, with time and experience, productivity will increase. The manufacturers learn to solve the problems, so there'll be fewer defective chips, fewer errors, and productivity will go up, and that makes the cost decrease. So we're looking at a shift downward of the cost curve, even though we haven't changed the factory, we haven't changed the workers, and we haven't changed the technology. We're just using better technique. We're solving some of the problems, and that's the idea of a learning curve. Sometimes this is called learning by doing. Right? Productivity increases with cumulative output. Right? Not just how much we're producing at a given time, but how much we've produced altogether. And the more experience a manufacturer has, the more they will learn and the lower their cost will be. And this has been observed in many different industries, in military hardware, in chemical manufacturing, in synthetic fibers, in consulting, in services. Now, one of the earliest studies from 1950 by an economist named Alchian looked at aircraft produced in World War II. And here, and this was really a puzzle, why did productivity increase so much without any apparent change in technology or in workforce? But looking at a particular factory, the first plane took 1,000 hours of labor to produce. By the eighth plane, the company had learned to do things better. Again, not a new technology, just making things work more smoothly, and the cost had dropped in half. By the 50th plane, it was a quarter of the cost. And the 100th plane was 227 hours, right, compared to the 1,000 hours for the first plane. Again, same factory, same machines, same workers, just learning to do things better. Now, learning curves give a big advantage to an industry leader. Once they have moved down the learning curve, so maybe an initial chip will cost $500 to produce, but once they've learned to produce it and once they've perfected the manufacturing process, maybe the cost drops to a fifth that, to only $100. So firms that have more experience will have lower cost than a new firm. Now, of course, the size advantage depends on the amount of cost or the value of the learning, as well as how many times do you have to do it. Do you have to have hundreds of batches to lower cost, or does it happen pretty quickly? If it happens quickly, a follower can catch up. If not, the learning curve can be a significant barrier to entry. Again, it's a barrier to entry because followers are at a disadvantage. They'll be producing at $500 where an incumbent might be able to produce at $100. In some cases, followers can never catch up, and in that case, the leader would dominate the industry. Now, learning curves generally lead to pricing problems. If the initial cost of a chip is $500, because we haven't learned very much about how to produce it, we know we won't be able to sell too many of those chips if we charge a price over $500. Right? We'll be on a very far upper left of the demand curve, a low quantity. And that means we will gain our experience very slowly. What we'd like to do is sell a lot of chips, and that means setting a lower price to start with. So we could charge, say, $150. There's going to be a much larger quantity demanded at that point. Right? We'll be selling below cost to start with, but our cost will be dropping because more people will be buying our chips. So essentially what we're taking is a loss now, but we're investing in future cost reduction. And of course, that $150 price will be profitable, right, once we can drive our cost down to $100. But this becomes really complicated. We're pricing below average variable cost, what would normally look like predation, but if we do have significant learning curves, it might be perfectly rational for a business to do that. A second problem with learning curves and pricing is that while low prices are rational, they're not problem-free. Often, new chips are competing directly with old chips from the same manufacturer. And so new chips have to be priced low enough to attract customers from that previous chip, and we have substitution between generations. If we do price it low in order to increase the quantity demanded, we may run into production problems. Right? One of the reasons microchips are so costly to start with is we have a high number of defective chips, chips with errors that makes them not work. And so those defects cause output constraints. And so if we start with low yields of good chips and we're pricing them low, we then may run out of chips, maybe unable to satisfy the demand. And so we see in many industries that it's common that we'll have shortages with a new generation of electronics. And often firms will lose money in the beginning, and they will also resort to non-price allocation, perhaps limiting the sales to certain favored customers. Another possible problem with learning curves is we could have a hyper-competitive equilibrium if we have a couple firms competing to be the industry leader. It's possible that firms may cut their price so early or so much early on in order to gain lower future costs that they sell below average variable cost. But if there are rivals who are also keeping prices low in order to keep their production high, all the firms might lose money. They may never get high enough return on their sales. They may not make enough profit to cover their fixed cost, their investment cost to start with. Learning curves, when we do have a single leader, do tend towards a dominant firm or sometimes towards monopoly. What I'd like to look at is why don't learning curves always create monopolies? One issue with learning curves is eventually the learning curve flattens. Production at some point becomes perfected. The costs don't drop any further, and so the dynamic advantage that goes to the leader eventually declines. And a follower who reaches that point, the flatter point on the learning curve, will find that they can compete effectively. The second movement away from monopoly may be a strategic choice by buyers. Buyers may intentionally cultivate a second producer. This reduces the risk to the buyer of holdup problem, right? And so they may intentionally keep a smaller follower in business, paying more for those chips in order to maintain rivalry in that segment of the industry. A third factor that limits learning curve advantages is that learning can move across firms. As the process improves, information may spread to rivals. And that information may be transmitted by employees who quit one company and move to another one. It may be transmitted by consultants who are hired to solve problems in one manufacturing plant and then can take those solutions to a rival manufacturing plant. Or it could be suppliers who are providing some of the equipment to a chip manufacturer may solve problems for that manufacturer and then try and apply those same solutions to all of their customers. A final constraint on learning curves is that technology in these industries tends to change very quickly. And the new products come in, and while they may be at the very top of their learning curve, they may be enough better that customers are willing to buy them um, and displace the previously dominant firm. Thanks for listening. This has been Chuck Stahl from Kalamazoo College.